Let's talk about Module 14. In Module 14, we will continue with Chapter 9. Last week, we introduced what are pointers and how to pass in the pointer through the function. So this week, we will continue to finish Chapter 9 and introduce dynamic memory allocations. So the first thing, we will give you the example what are dynamic memory allocation. So we will create the dynamic memory and refill by the pointer. And also continue talk about passing the pointer through the function. We also can return pointer from the function. And on Wednesday lecture, we will continue to talk about how to use the constant keyword to work with the pointer. In C++, that's very important. When we create a dynamic memory allocation, we also need to clean the memory. So in C++ 11 and after, they also show you how to use the smart pointer to avoid the memory leak. So just like Java and the Python, they will automatically to do the garbage cleaning. But the first thing that's in this video, what are dynamic memory allocation? So the first thing we should know, when we talk about all the variables we create from the beginning to last week, they are not dynamic memory allocation. For example, we can specify a variable is int variable x, right? So we assign that equal to 5. So remember before we show you this integer variable, they will allocate 4 bytes from the memory. Then we assign the value is 5. So those things actually is the state. So those variables we define, they are static memory. They will reside the memory in the stack memory. And also after the program finish, those memory will be cleaned automatically. So even the array we talked about before, remember we can have an int array. Maybe we call array 1. So the size is 5. So then we can allocate the value. So the same thing, those array we create, they are static. So those static memory, actually after your program finish, the program will automatically to remove those memory. And those static memory, actually you cannot reallocate the location. For example, you already have X, so that memory location you cannot change, but you can reassign the value. So the same thing, the array, remember we told you after you create, if the size is 5, then you cannot change the size because they are static memory. So now, opposite to the static memory, we will have the option in C++. We can do the dynamic memory allocation. So this dynamic memory allocation can allocate the storage for a variable when the program is running. So when you create the dynamic memory, they only return the address for the newly allocated variable. Because they have a location you need to locate it and store, right? So here, how to create a dynamic memory, we're using the new operator. For example, you can new double. So when you new double, that means you allocate. So you allocate a dynamic memory location of a double variable. So that they will, in the memory, what happened is, right, they will locate a double variable size will be 8 bytes. So for example, here I have 8 bytes. Okay, so here actually this location will be in the heap memory. So this heap memory will be tells you where they are located. So they are not one by one like the static memory the program assigned at the beginning. So they will go to some dynamic memory allocation pool. Also usually that's in your RAM location, in your computer in the RAM. So then here they assign the 8 bytes. But when they assign this 8 bytes, they need to know where, right? Because you are new. Double, they only allocate the 8 byte location. but the location we didn't know. So whenever you using the new keyword to allocate the variable size location, so then they will return you the address. Also remember we say the address is the beginning of this 8 byte. Like that, so double 8 byte. So that's why here, after you create, we need to know how to access that, right? So they return you the location, the beginning of the address. So that's why when you assign, we need to save in where, right? So that's last week we introduced you the pointer. The pointer, after you create a dynamic memory allocation, we need to have a variable to save the memory location. So that's why you need to using the pointer to save. But the pointer, remember, because you are create a double variable, so I need to create a double pointer. Okay, so this double pointer I call dptr. Whenever we create a pointer, if we didn't know the location yet, so then we assign to 0. That's a no pointer. So then afterward, use a new keyword to create this 8 byte, right? So now here, the dptr. So dptr actually is a variable. So that's why you see that's a dptr. So this dptr will using, so that's why usually when we show you the picture in the memory, we do what? We do this. We use the arrow to show. Okay, so actually this dptr, they are standalone variable. But after you knew, you assign the memory location to save in this variable. So the kind of is this variable refer to this location. So that's dynamic memory allocation. Whenever we create a dynamic memory allocation, they're using the heap memory. So then we use the new keyword. So this new keyword, they will return you the address. So you need to use a pointer to save that location. So then before you create the new, so don't forget, according to the data type you want to create, you need to match your data type for your pointer and the location you want to create. So that's why here, let me show you that. Oh, I just highlight that the same color, that's double data type. So here I show you how to using the new keyword to create dynamic memory allocation and how they happen in the memory. So the next one, we see the example 12. So we see in example 12, right? So the first thing we define a pointer, the data type is double. So that's dptr. You can either do the no ptr or 0. So sometimes different IDE, they may ask you have different keyword. Like the S code, they call no ptr underscore t, but the easier way, you can just do the 0. So that just means they are the no pointer. They are not referred to anywhere. So then after we have the new keyword, right? So we use the new keyword to create a double size location. So this location, we will refer to the dptr. So then after you assign this new location to the pointer, right? Remember, we can do the dereference to assign the value. So then after we assign the dptr, that location value is 10.0. But this 10.0 actually happen in where? They happen in here, right? Because that's the dptr refer to. So then afterward, you can either using the dptr alone to show the memory location, or you can do the dereference to display the location value where they refer to. And one thing is, when we talk about using the new to create dynamic memory allocation, we also need to use the delete. Because remember, we told you, when you have your static memory, the program finish, all the static memory will be released. But in C++, if you're using the new keyword to create dynamic memory allocation, after your program finish, those memory won't be released unless you call the delete. So then they will release those memory location to the free pool. So sometimes we say, if you're using the new to create the dynamic memory allocation, then you didn't delete. What happened? actually nothing really happened, you will see, because your program is still finished. But for long term, those memory not being free to the freeze pool, then your memory will have baggage. So that's why we say your memory will become smaller and smaller that memory can use. So that's what we call the memory leak. So that's what we need to use the delete to free the dynamic memory. So this one, if you don't do that, honestly, you won't see what happened right away. But long term, the memory will leak. That means you have less free memory to use. Your computer will become slower. Right, so we still need to run the program on the IDE, right? So that's here. Make sure you download example 12. Then you want run on IDE. But one thing is I want to continue. When you're using the new keyword, you can create only one variable, but you also can create an array. So let me continue with the PowerPoint file, so then I can run this program with you. So one thing is, right, so when we're using the new keyword, we also not only can create one variable size. You can be int, can be double, can be string, can be char. But also you can create a locate array. So when you create the array, right, you're just using the same thing we're using the new keyword. So this new keyword actually just will be the same as your array symbol. For example, I want to create a double array. So the good thing is when you're using the new keyword, right, before when we're using the static memory, your array size need to be constant number or the immediate value or constant variable. But when you're using the new keyword to create the dynamic memory allocation, then this size can be any variable. That means can be a non-constant variable size. So this size, actually you can see I define int size equal to 25. I don't have the constant keyword. So that's why you can have the non-constant variable to allocate the array size. So afterward, you see, right, your array name actually become what? Yeah, you're just using your array pointer, right? So here we create, because your array is double, so I create a double pointer. So then this pointer I call array PTR. So then you see here, when you after using the new keyword to create the array, right, your array look like this. For example, we have 25 size. Okay, so our array here is new, is in the heap memory. Okay, but you see they cannot access this location for beginning of the array. So that's why we need to have the pointer. So now after you have pointer to refer to the beginning of the array, this pointer name, right, before we told you, right, the pointer name actually just exactly work like your array name. So when you're using the dynamic memory allocation, you're using the new keyword to create the dynamic array. So then you're using the pointer to refer to that. Then afterward, your pointer variable name can just work like array name. So you can have a for loop for I equal to 0, I less than the size. So then your pointer name can associate with your square bracket operator. So then you can assign the value. Of course, if you want, remember, array name or pointer can just using the arithmetic for the pointer arithmetic. So then you dereference. So either way is fine. So that's why here we show you. You also can create dynamic memory array. And of course, at the end, after you create the array, you also need to delete that. Okay, so then with the same thing, we go back to see our example 12. So example 12, you can see here, I have a size equal to 10. So then after I create that, I also using the dptr, you see. So earlier I already created the dptr, right? So then you can using the dptr to refer to that dynamic memory allocation for the array. So then we just assign the value one by one. So then when you want to display all the array, of course, you can using the square bracket to access that.